Alright, this is Mr. Gillum, and today we're going to look at the instruction book on pages 36 and 37. This is an independent practice exercise, so I want you to try these problems on your own before viewing this video to see the answers. Anything that you made a mistake on or you need to change or modify, I want it to be changed or modified so that you have the correct information in your instruction book always for reference. Corey knows that 16 tablespoons are the same as 1 cup. He needs to measure 3/4 cups, but all he has is a tablespoon. How many tablespoons should Corey use? Alright, so this problem is going to probably lend itself best if we draw a double number line. And we try to keep the increments the same because we are going to be dealing with fractions on this problem. Maybe a little added challenge from what we've been doing in the past. So I'm going to put tablespoons on the top, and we can put cups on the bottom. And I'm going to use the given information. He says that he knows 16 tablespoons is the same as 1 cup. Now, the question asks about 3/4 of a cup, so I really need to know about less than 1 cup. I know 3/4 is less than 1, so I'm going to put the 1 cup over here. 1 cup for 16 tablespoons there. And I'm going to make smaller divisions of my number line here on the left side. So I'm looking for the 3/4 mark, and so I might not know exactly where that's at. Maybe some of you know already that 12 is 3/4 of 16, which is awesome. But if you didn't know that, we would have to divide this into a little bit smaller pieces. So the first thing I'm going to do is divide both 16 and the 1 by 2. I'm going to put that right in the middle here. I know that 1/2 would go with 8. Okay, half of 1 is 1/2. Half of 16 is 8. So I have that one. Now, some of you may realize that, oh, okay, well, 3/4 is exactly halfway between 1/2 and 1. So the number halfway between 8 and 16 would be 12. That would be one way that you could find the answer. But some of you may not know that at all. So let's divide it by 2 again. If I divide 8 by 2, I would get 4. And if I divide 1/2 by 2, I get 1/4. So you can think of it kind of like this. So a whole divided by 2 or it makes halves, and a half divided by 2 makes fourths, and I continue to divide and make smaller and smaller pieces if I wanted to, but I think now that I have everything that I need to solve this problem. If you want to think of 1/2 as 2/4, you can see that whether I think of the circle as 1/2 or as 2/4, it's equivalent. Those are the same thing. So I know that I have 1/4 and then 2 more fourths. If I add those together, that would be 3/4, and that's the value I'm looking for. I think my pen lagged on me. There we go. And then 4 plus 8 would be 12. So you could see 12 as well. So you could think about it as being halfway between 8 and 16 after your first division. You could think about it as being 1/4 plus 1/2 is 3/4. 4 plus 8 is 12. So this is the value that we were looking for. So in this case, it would take 12 tablespoons for 3/4 of a cup. Come on, there we go. Go back. Okay. Laggy computer. It says Mrs. Rosso has to travel 390 miles on a highway. She drives 130 miles in 2 hours. If she has 7 hours to travel at that rate, will she arrive at her destination on time? So I think of this as a unit rate problem. When I think about it, it says this is how far she has to travel. This is not part of the problem. This is actually part of the question. That's how far she has to travel. The given information says that she travels 130 miles in 2 hours. 130 to 2. If she has 7 hours to travel at that rate, will she arrive at her destination on time? So what I want to do is I can think of it as, well, this might actually be easier to use a table for this one. We can do it both ways. On the top we can put miles. On the bottom we can put hours. And the given information says 130 miles in 2 hours. Now I need to figure out where 390 is. I know the unit rate in this case, if I divide both sides by 2, would be 65 to 1. So I know that 65 to 1. I know that 1 plus 2 is 3. 65 plus 130 is 195. I could do this pattern all the way down until I get to 390, or I could skip some. Instead of adding 65 every time, I think it's easier to actually multiply by 2. So that'd be 260 and 40, or 260 and 4. I'm going to multiply that by 2 again, or I could say, okay, I think this is the value that I'm looking for. 2 plus 4 is 6. 130 plus 260 is 390. And so by using this table, I can see that it will take her 6 hours to travel 390 miles. So you can see that they've chosen choice A. Yes, it only takes her 6 hours. She has 7 hours. She has an hour to spare. She'll arrive 1 hour early. If we wanted to use the unit rate, we could say, well, she's got to go 390 miles, and we know that she goes 65 in 1 hour. So if I figure out how many 65s going to 390, and each one of those takes an hour, I can figure out how long it will take her altogether to go 390 miles. So this, unfortunately, is not going to be a very fun long division problem, and so this is part of the reason why we learn how to do several different ways. When I divide 390 by 65, I know that'll go in 6 times, and that just so happens to be exact. And I knew that already because I already found it in my chart. So a long division problem like that wouldn't be necessarily that beneficial to use the unit rate for. So I mean, it's important to know different ways to solve, especially if maybe your division skills aren't the best. A table might be a little more appropriate for you to use. It says at Mark's Hardware Store, a package of 8 hinges costs $28. At Steve's Supplies, a package of 11 hinges costs $38. Which statement is the most accurate? It says Mark's Hardware is the better buy because it sells hinges at $3.50 per hinge. Mark's Hardware is a better buy because $28 is less than $38. Steve's Supplies is the better buy because it sells hinges at $3.45 per hinge, or Steve's Supplies is the better buy because you get more hinges. So it sounds to me like each of these multiple choice options has to do with which is the better price. Okay, it doesn't say that in the problem itself, but in the multiple choice answers it seems to be comparing the price of each one. So I'm going to find the unit rate for both Mark's Hardware and Steve's Supplies. And I think it might be easier actually, again, Mark's Hardware and Steve's Supplies. It might be easier to do a chart on this one because I think that if we do long division, it'll be, they won't work out very well. We'll start with Mark's Hardware. It says each one costs $28. Cost on top and hinges on bottom. And then at Steve's Supplies, 11 hinges cost $38. Okay, so this is going to be a tough problem to solve. We're going to be creative with the patterns that we see. Let's start with Mark's Hardware. Let's divide both 8 and 28 by 2, so 14 and 4. And we'll divide that by 2 again, 7 and 2. And then I can divide that by 2 again, 1, and in this case, 7 divided by 2 is 3.5, or $3 in this case. We're talking about cost and 50 cents. So I know that Mark's Hardware for one hinge costs $3.50. That is his unit rate would be 3.5 or $3.50. Now, Steve's Supply is going to be a lot tougher to figure out how much one would be. Maybe I don't know. I'm not sure what the best route would be to take on this chart. This would be the cost, and this would be the hinges. So let's see here. What if we did? I think it's going to be hard to avoid long division on this one. Let's go ahead and divide 38 by 11. Okay, so we're thinking about the ratio 38 to 11, and I'm finding the unit rate for this one. So 11 goes into 38 3 times. If I take away 33, there's my decimal. I'm going to go ahead and bring my 0 down. And now 11 goes into 54 times. Minus 44. 6. 0, bring that 0 down. 11 goes into 65 times. Minus 55, which is 5. And it's going to keep going and going. But bring it down to the next one here. So it's not exact, but it looks to me like it's going to cost about $3.45 for hinges at Steve's Supplies. Even though it's not perfect, when I compare to see which one is which statement is the most accurate, C is a good choice because it says it's a better buy. The hinges are less per hinge. One hinge would cost $3.45 at Steve's, and it would cost $3.50 at Mark's. So it's not much difference, but Steve's is slightly less expensive, or more inexpensive. Elena can swim 12 laps in 4 minutes. Fill in the blanks in the double number line to show this relationship between laps and minutes. So I believe it gives you these boxes to fill in on your paper. And the initial values that you should know to put in would be the 12, because 12 and 4 go together. And then there's a relationship. I look for the relationship between the numbers. So 4 times 3 would be 12. And if I went the other direction, it would be 12 divided by 3 equals 4. So I would look through these, and I see that I can use that pattern for this one and this one. So 20 times 3 would be 60. So that one could be filled out pretty quickly. And that's already done. Those would be my multiplying by 3. If I wanted to go the other direction, this way, I would divide by 3. So 24 divided by 3 would be 8. 48 divided by 3 would be 16. 72 divided by 3 would be 24, and 84 divided by 3 would be 28. Now, I think that you're going to have a harder time on this last one. Let's divide by 3. I don't think you're going to be able to divide by 3 using the unit rate. I think you're going to have to add two numbers together, like say maybe 20 plus 20. No, not 20. Like 4 plus 24 would be 28, so 12 plus 72 would be 84. You could also just increase each of these numbers by 12 each time and probably figure out all of the values that you're missing. So you could do it that way as well, and then increase the values on the bottom by 4 each time. And just keep increasing by 4. There's a lot of ways to do the chart. I'm comfortable. I feel like we're going to be pretty good at that one because we've done a lot of those charts where we have to fill in the blanks. There are 4 cups in a quart and 4 quarts in a gallon. How many cups are there in a 5-gallon jug of water? Show your work. Okay, so this problem is going to be pretty challenging actually. I'm going to start by drawing a visual, and then I'll try to explain it using multiplication and the unit rate. So I'm going to draw a picture of a cup, a quart, and a gallon. The best that I can, and the best sizes that I can to represent how much each one is. If I look at it closely, we're going to call this a cup, this a quart, and this a gallon. It says that 4 cups will fit in a quart, so I could divide each of these into 4. Cup, 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 cup. And each gallon has 4 quarts. So this is a quart. Each of these is a quart. And then there's a cup for each one of these little divisions here. So when I think of it this way, and visually, it makes the problem make a little more sense. If I was trying to do this with mental math, it might be more challenging for me. So you can see that 4 cups fit in a quart, 4 quarts fit in a gallon, and so if there's 4 quarts in a gallon, there must be 16 cups in a gallon. All right, but it doesn't ask just how much is in 1 gallon, it asks how much is in 5 gallons. So if I know there are 16 cups in 1 gallon, to find how many there's in 5 gallons, I would need to multiply. That tells me that there are 80 cups in a 5-gallon jug of water. Now the book explains it a different way besides the model that I just drew. It says that if there's 4 cups to 1 quart and 4 quarts to 1 gallon, then 4 cups times 4, you can see this is what we did right here, 4 cups times 4, 4 times 4 would be 16 cups in 1 gallon. And just like we did over here, if there's 16 in 1, then we need to know how many are in 5, then we would multiply 16 by 5. So that would be 80. Looks like I'm going to have to make a second video for this one because I'm going to run out of time.